All right, everybody, we're back. We're still factoring some GCFs. I said I would do a second video doing some examples just to break things up a little bit. So here they are, 5 examples where we're going to factor these polynomials into its factored form. So if you didn't watch the original video where I go over the explanation, you could do that. I'll try to link it here in the corner. But yeah, in that video, I said there was a 3-step process. Okay, step 1 is find the GCF of all the terms in the polynomial. Step 2 is divide by that GCF. And then step 3 is write your answer as a smaller polynomial group times that GCF on the outside, right? Because what we're doing here is reversing the distribution process, okay? So step 1 for all these is find the GCF, okay? And we kind of have to do this separately between the numbers and the variables, okay? So just the numbers first. This one's going to be pretty quick. So I think 8 and 10. And again, with factors, I'm thinking what all multiplies to give me 8, and then what multiplies to give me 10. Okay, so 8, right? I can think 1 times 8 is 8. 2 times 4 is 8, right? That's it. Okay, and then for 10, 1 times 10 is 10, and then 2 times 5 is 10, right? And so my greatest common factor, the highest number that both of these have as a factor would be 2, right? That's the highest number that is in both of these lists, okay? So my GCF, I would say, is 2, okay, but not just 2, because I have to look back at this. And again, my rule was, my shortcut before was, if all the terms in the group have a variable, then you pick the one with the lowest exponent to be included in your GCF, okay? And so I look at this and I think x squared, and this is just a single x, but remember a single x is x to the first, right? So out of these two, right, those are the only 2 terms in the group, so x squared, x to the first, so my lowest exponent would be x to the first. Okay, so that's saying in common, they both have at least one x, okay? So that's step 1, find my GCF. So I did that, 2x to the first. Step 1, complete. Step 2, I need to divide each of my terms in this group by that GCF. Okay, so I divide by the 2x to the first, both terms. So I did that, and now I actually do the division. So, right, and this is when we divide polynomials in these terms, my rule is divide the big numbers, subtract the little numbers. Okay, so divide the big numbers, 8 divided by 2 is 4, and subtract the little numbers, 2 minus 1, so that's 4x to the first, right? Subtracting those. And then my second term here, 10 divided by 2, divide the big numbers. 10 divided by 2 is 5. Subtract the little numbers, 1 minus 1 is 0, but again, when we have x to the 0 power, we don't really need to write it because it's basically all the x's canceled there, okay? So that's step 2, is I have my division, right? And so I divided both of those terms. That's step 2. Step 3, I write my problem as the beginning of a distribution problem, right? So that would be like there's a group, a smaller group, which I have from the division, and then there needs to be a term on the outside, right? And that term on the outside is my GCF, okay? So that GCF number, that term 2x to the first is written on the outside here, okay? So this is my final answer, okay? So that's the process. Step 1, find the GCF. Step 2, divide by it. Step 3, your smaller group times your GCF on the outside, okay? So that's the process. We're going to do that 4 more times. Some of these problems are more complex than others, so you're welcome to skip ahead till I go over some problems that you might want to see. But just one more simple one, and then we'll get into some of the tough ones, okay? So again, just that process, GCF, right? Step 1. So I need to find that, right? So I have 2 terms. So 12x to the third minus 9x squared. And I said here the signs aren't super important. They are, you want to keep them in mind, but they don't affect really what your GCF is, okay? So out of 9 and 12, or I guess 12 and 9, but those are the numbers, right? So 9 would be 1 times 9 and 3 times 3, right? 12 is 1 times 12, 2 times 6, and 3 times 4, right? And so that's all the factors of 9 and 12. And so I think for this one, okay, what's the highest number that's in both lists? And so that would be 3, right? They both have 1 as a factor, but they also both have 3 as a factor. So 3 would be the greatest common factor, right? So 3. okay? But don't forget, you need your variable part too. So you look back at your group and you think, okay, do they all have variables? Yes, they do. And so for that, I would think, okay, what's the lowest amount of variables, or what's the lowest exponent, right? So this one has 3, this one has 2. So in common, they would have both at least 2, right? So we would say 3x squared. You put that lowest exponent in your GCF. So this GCF is 3x squared. So step 1, good. Step 2, I divide by that, right? So divide by 3x squared, divide by 3x squared, okay? And that's going to give me my smaller group. That's going to be kind of that group in my answer, okay? So I divide these, again, following that rule, divide the big numbers, subtract the little numbers. So 12 divided by 3 is 4. X to the third divided by x squared. So 3 minus 2 would be 1. So that's 4x to the first. And so this is, you just bring down this minus, okay? Because the signs are going to stay the same, because your GCF is never going to be like a negative number, okay? Sometimes it is, but we'll deal with that later on down the road. So I would think 9 divided by 3 is 3. X squared divided by x squared. Again, 2x's would be 0x's, and that would cancel, right? So 4x to the first minus 3 would be my smaller group in there. So step 2 is good. I did my division. Step 3, I write it as a polynomial times the GCF. So I just need to write the GCF here on the outside, 3x squared, and I'm all good. Now, here's how you check your answer. Okay, let me do that for this one. Again, obviously what we just did was we reversed the distribution process, right? That's what we've been doing, is we kind of divide out a term from the group. So we write it as the beginning of a distribution problem. So obviously if you want to check your answer, you could just re-multiply that, okay? And if you re-multiply that and distribute it, you should end up right back where you started, right? So if I multiplied 3x squared times 4x to the first, again, this is the rule that says multiply your big numbers and add your little numbers, right? Kind of the opposite. So 3 times 4 is 12. X squared times x to the first. 2 plus 1 is 3. 12x cubed, okay? And then I have 3 times the negative 3, negative 9. X squared times no x's here, so that's just going to stay x squared. And does that match what I had originally? Yes, it does. Awesome. So you're good. 3, 4, and 5, a little bit bigger ones here, okay? So for number 3, again, I have 3 terms here. So yes, for my GCF, I do need to worry about, it has to be a common factor across all 3 terms, okay? So for my GCF here, I think about 4, 12, and 30. Again, and some kids might be able to find the GCF without making these lists. And if you can, awesome, okay? But they're there to be helpful so you can see what all the factors are. It can be easier for some kids too. So for 4, right, 4 would be 1 times 4, 2 times 2, right? For 12, 1 times 12, 2 times 6, 3 times 4. And then for 30, 1 times 30, 2 times 15, 3 times 10, 5 times 6. So again, like, it has to be common across all 3 terms, right? So we could say, like, if it was just 12 and 30, we could say 6, right? 6 is a common factor amongst those 2, but again, it has to be common amongst all 3. All 3 have to have it. So for this then, we could really only say 2, right? All of them have a 2, and all of them have 1, but 2 is obviously bigger. But yeah, other than that, they don't have any. All 3 of the numbers don't have the same factors. Okay, so 2 is going to be my highest common factor. So 2. And then again, I look at my variables, and I think, okay, first off, do they all have a variable? X to the fourth, x to the third, x. Yes, they do. Okay, so if they all have a variable, we include the x in the GCF, okay? But again, we pick the lowest exponent because, like, if I said x to the fourth as my GCF, like, this doesn't have x to the fourth or 4x's, right? This just has 1. So they wouldn't have x to the fourth in common. So in common, they all have at least 1x, right? If you said anything more than that, then that would kind of discount this term right here. So 2x. 2x is my GCF, okay? So again, I know some of these terms are a lot bigger than that, but just like in real life, Some people don't have very many things in common, and that's true of terms, math terms as well. Sometimes these groups contain a bunch of terms with not a lot of factors in common. And that's okay. Our job is to factor out what they do have in common, so we'll do that. Okay? So step 1, find my GCF, 2x. I did that. Step 2, I divide everything by that. Divide by 2x, divide by 2x, divide by 2x. Okay? And now I actually do the division, right, to get my smaller group. Again, all these have 1 exponents as well. That'll help me with the subtraction, right? Divide the big numbers, subtract the little numbers. So 4 divided by 2 is 2. X to the 4th divided by x to the 1st would be x to the 3rd, right? 4 minus 1. Plus 12 divided by 2 is 6. X to the 3rd divided by x to the 1st, 3 minus 1, x squared. Okay? And then last, 30 divided by 2 is 15. X to the 1st divided by x to the 1st cancels, right? 1 minus 1 is 0. Okay? So there's my group. Okay, so step 2 is good. I divided. I got my smaller group. Step 3, write it as a distribution problem. So I'm just so used to writing my parentheses early, so it's good to do that to remind you. But then, yeah, also your 2x, your GCF, is written on the outside of that. Okay. And again, I'm not going to do it for this one, but if you wanted to check your answer, remultiply that, you should end up right where you started. Okay. Now, number 4, I like this one because it's a little bit tricky. Okay. So 12x minus 32. Okay. So very simple, but it can trick up kids because it's not like similar. It's not similar to a lot of the problems you see when you're asked to factor a GCF. Okay. So 12x minus 32. So we think out of 12 and 32, which factors do they have in common? So let me list these out real quick. Okay, so here's all my terms. Okay, 12 and 32. And again, this is why it is helpful because these are numbers that have some common factors, but like they're also problems that kids might they're numbers that kids might make the mistakes and say, yeah, oh, 6 is a factor of 32 or 8 is a factor of 12, right? Because one of the numbers has it and you think, oh yeah, it's an even number, so they both have to have that, right? And so that's why it's helpful to list them out. Just again, get in the habit. And listing them out also kind of helps your brain to remember, oh yeah, what are those times tables, right? Throw back to elementary school. So it definitely helps. So if you want to make the list, I would definitely encourage that. Okay. So again, we look at our list. What's our highest common factor in both lists? It would be 4, right? 4. And then again, we go back. We have to remember our variable, right? Do both terms have a variable? No, right? This is our first one where that answer is no. So what does that mean, right? Well, again, GCF is all about what do the terms have in common as factors. So if we said 4x, that wouldn't be true, right? Because 32 doesn't have an x, right? So we wouldn't say that's a common factor. So that's why when I said that, I said, okay, pick the lowest exponent if they all have an x. If they all don't have an x, that rule no longer applies because they don't have that in common, right? So this is another example of where we have 2 terms here that don't have a whole lot of factors in common, okay? And so we just say the GCF is 4, all right? So we move forward with that as the GCF, okay? Now that's step 1, find it. Step 2, divide, right? Divide by 4, divide by 4. So 12x divided by 4 would be 3x, right? I'm not dividing any x's, so that stays the same. And then 32 divided by 4, 8, right? 8. And then again, step 3 would be writing that GCF on the outside, okay? Now I mentioned in the end of problem number 2 that sometimes there's another way to check other than like just distributing and ending up back where you started. Sometimes there's a situation where you picked a common factor, but like you didn't pick the right common factor, okay? So for example, some kids might look at this and say, oh, maybe 2. Maybe 2 is the common factor, okay? So let's say you did that. Let's just say you chose a common factor that wasn't the greatest, okay? So if you divided, look what you'd end up with. You'd end up with 12x divided by 2 is 6x. 32 divided by 2 would be negative 16, okay? And your 2 would be outside. It's almost like reducing a fraction, right? So like 4/8 reduces down to 2/4. And that's true, like these are equivalent like you could say these are the same fraction. But you can reduce it further, right? Like this, you did reduce it, but you could reduce it further down to 1/2, right? And the same would be true here. Like, yes, you factored out a common factor of 2, but you didn't factor out the greatest common factor, right? And so that's really the goal here, is factoring out whatever our highest, our greatest common factor is, okay? And if you like, the problem here too is like if you redistributed that, like you would end up back at the beginning. So you'd be like, oh yeah, I did it correct, I'm good, okay? But the giveaway, here's a giveaway too that you might notice, okay? A lot of the time, if you pick the wrong common factor, if two numbers are even, they have a common factor of 2, which means you could have chosen a bigger number here, okay? So a lot of the time that's true. If the numbers have that extra common factor that you didn't catch at first, that just means you have to go back and you say, okay, instead of dividing by 2, I got to divide by 4. But again, a lot of the time, the kids that do that are the kids that don't make their lists. So again, just I'm advocating big time for you making your lists, okay? All right, last one here, and then we're all set. All right, new color for a big problem. Okay, number 5, 7x squared y plus 10xy cubed plus 22x cubed y squared. Wow, lots of numbers, lots of variables, okay? Process is still the same though. Step 1, find your GCF. Okay, find your GCF. So again, we look at our numbers, 7, 10, and 22. Now here's a little shortcut with this too, because I know, again, with 3 numbers, you might be like, oh, I don't want to make those lists every time. Now here's something, okay? When we start with 7, okay, 1 times 7, right? Those are the only 2 factors of 7, right? 1 times 7. You can't think like 2 times something doesn't equal 7, 3 times something 4. None of those numbers multiply to give you 7, okay? So you have 1 and 7 here. For there to be a common factor across all 3 terms, there has to be, like, again, 1 is a common factor automatically, right, of every number. Like 1 times something, 1 times that number gives you that number every time. But it would also have to have 7, right? For there to be a common factor, right, you'd have to do 7 times something to equal these. Okay, and that's not true, right? 7 times something can't equal 10, right? Or not a whole number. And 7 times something doesn't equal 22. Okay, so this is a situation where, like, you could say a GCF of 1, but again, that's not like when, because you think about what do we do with the GCF? We're dividing each of these terms by that, and dividing by 1 doesn't like reduce any of these numbers at all. So saying a GCF of 1, it's true, but it's not going to change these values at all. But we still have variables here, right? So like I'll say 1 here, but I'm not going to end up showing that when I divide. So I have 2 types of variables though, right? I have x squared, I have x to the first, I have x cubed across those 3. So I'm just focusing on the x's right now, and my rule still applies, right? I think, okay, do all the terms have an x? That answer is yes, yes they do. And so you think, okay, if that's true, I have to choose the lowest number of x's that any of the terms have. So this is x squared. So 2 x's, x to the first, 1x, x to the third, 3 x's. So x to the first would be the lowest exponent, right? So that would include that in my GCF. And then for this one, 7x squared times y to the first, right? So y to the first, y cubed, y squared. It's the same thing. The lowest exponent across all the y's is 1, right? So 1, x to the first, y to the first would be my GCF. Okay, again, another example of big terms, not a lot in common, but again, we'll divide out what they do have in common. Okay, so step 1, find the GCF. Did it. Step 2, divide by it. So x to the first, y to the first is what I'm dividing by. So I divide everything by that. Okay, and again, that's going to end up with a smaller group, and not too much smaller because I'm not dividing by much, but I'll divide, okay? So all the coefficients, the big numbers, are going to stay the same because I'm not really dividing by anything here, okay? So it's going to be just 7, and then I divide x's. So x squared divided by x to the first. So for all these, it's going to be subtract the little numbers, okay? So 2 minus 1 on the x's gives me x to the first, then y to the first divided by y to the first, would be 0, and those y's cancel. So my first term is just 7x to the first. My second term is plus, again, the 10 doesn't change, so just 10. Then x to the first divided by x to the first cancels, so I'm good there. Y to the third divided by y to the first, 3 minus 1 is 2, right? So 10y squared is what that second term ends up being. And then my third term, last one, 22 divided by nothing is just 22, right? X to the third divided by x to the first gives me x squared, right? 3 minus 1. And then lastly, 2 minus 1 on the y's gives me y to the first. Okay, so that's step 2, divide. Step 3, that GCF is written on the outside, x to the first, y to the first. So there's a whole bunch of examples for you of factoring GCFs. Thanks for following. Hope it makes sense. Good job.